Hello? Oh, no? Test. Checking. All right, there we go. That's better. All right. Let's go ahead and get started. Hope you all had a great weekend. So this week, we're spending the entire week basically talking about databases. That's what we've got on the agenda. So the flick list stuff, we're kind of hitting the pause button on that for a moment. It's not going away. We're not done with flick list. We're just sort of taking a little detour, a little side route for a moment. And we're going to incorporate this stuff back into flick list starting next week. In fact, actually on Thursday, we're going to start talking about flick lists again in a little bit more detail. So our goal this week is to just learn as much as we possibly can about databases. Now, the prep work that they slated for you guys today, on a scale of like 1 to 10, this was like maybe a 50 in terms of quantity of prep work today. It was a lot. It was absolutely massive amount. So let's go ahead and start off by saying, if you didn't finish the prep work, or if you went through the prep work really fast and it didn't all quite stick with you, I get it, right? I'm with you on that one. I understand. So that being said, we do want you to learn this stuff. It is important. Actually, the prep work for Thursday is not as intensive. There's still prep work for Thursday, but it should not take you nearly as long. So I would encourage you to take some time between now and then to go back and brush up on some of the concepts from today's prep work. If you need a little refresher, we're going to talk about some stuff today. You're going to get some practice writing those things in studio today. So there are plenty of opportunities for you to catch up. I understand, though, that we asked you to do a lot and that there might be some gaps. So don't worry about that. Don't freak out if that's something that happened to you. The most important thing we can do is just keep practicing these concepts so that you can internalize them and put them to good use. So that's the plan for today. I am, along those lines, right? I didn't put everything in the review session for today. That would be insane. That would take forever. That would take the whole class. I'm going to try and hit on some of the highlights, some of the things that I think are important. But if there's something you saw from the prep work that was confusing to you, or you didn't understand, or you want to chat about it, feel free to holler at me anytime, or talk to your TFs about it if you want to go that route, or just make sure you get the help that you need before you leave here today. So let's go ahead and hop in. Let's talk about databases. First, how is data stored in a database? We'll start off simple. How is data stored in a database? If I peel off the top of the database and I look inside, what am I going to see? Columns and rows, which are organized into tables. Everything's in tables, and tables contain columns and rows. What does a table represent? There's another word actually you might hear referred to that's related to a table in the context of a database. I don't know if it was explicitly mentioned in the prep work or not, but even if it wasn't, you're going to hear it sooner or later. You're going to hear this idea of entities. This idea of entities coming back. So when it comes to deciding what a table is, we want that to be some kind of an entity, some kind of a real-world object in the general sense. It almost goes back actually to objects that we talked about in Python. So a person is a good table, right? Addresses could be good. Well, maybe not. A lot of it depends on the design of the database as well, but we're looking at real-world entities that we want to model in our database. So then what does a row represent in a database? What is one row? If we stick with our person table, what does one row tell me? It's one, that would be one, we call that a record or an instance. Actually, we've heard that word instance before. When we talked about objects, there's another relationship. A record, a row, an instance. To me, in the context of databases, those all mean the same thing. They mean exactly the same thing. One row in a table is an instance. So if I have a table that it's called people or person, then one row represents one individual person. Then what do the columns represent? Fields or attributes, right? Those are the descriptive pieces. So there would be a column for the person's name, a column for the person's birth date, right? Whatever kinds of descriptive information I want to keep about the entity, that's what goes in the columns. So that's the structure of a database in general. I mean, the interesting thing, or kind of the amazing thing to me, is that every single database that you come across, at least in this paradigm, will follow that same structure. Tables, rows, columns. Seems pretty simple, but can get very complicated when we have lots of tables that are interacting with each other in various ways. So it does get tricky. But at its core, that's what it is. Tables with rows and columns. It's all tables, all day. So why do we use databases? Why not just put stuff in code, or why not just put stuff into a text file and use it that way? Or, I mean, isn't Excel spreadsheets tables? Like, what the heck? Why do we need to make a database when we've got Excel spreadsheets? What's the big deal? Why do we use databases? I'm sorry? Enter at once. So having a centralized copy of things is a big deal to us. And databases help us with that by the way that they're organized. A lot of times we can have one database that's used by many different people, applications, whoever. So that's one big concept behind databases, is centralization, but that's not the only one. Why don't we just put everything in our code? That's what we did for the last few weeks with FlickList. Whenever I wanted a list of movies, I just typed the list of movies in my code. Why don't we just keep doing that? Make it easier to change? How so?
Depending on how many tables you have and how they interact with one another, you could just have someone's password change. Go to the password table, change that, and update it across everything. Different people can access it and update the records.
Sure, I agree with that. Although what I haven't, I agree with you entirely, but what I haven't heard is an explanation for why couldn't we just do that in the code? Yes?
Because HTML only takes one thing to get request at a time, and database allows us to hold multiple pieces of information at once.
HTML, so let me make sure I understand. You said HTML takes one thing in a GET request at a time by a thing? I'm not sure I understand.
Like one piece of information.
Is that true? Can I have a GET request that passes multiple parameters? Yes, actually we can. We can. I'm not sure if I'm fully, maybe I'm confusing the point that you're trying to make. I do agree with the statement that databases allow us to organize things more efficiently, compartmentalize things more efficiently. I absolutely agree with that.
Database, so every time you open a browser, you get the same information.
Yeah, it's consistency. What happens if I turn my program off? Then all that information is gone. It's gone. In other words, every time we start up the program, I have to re-enter all of that stuff, right? I have to re-enter all of that information. It's not persistent. Databases are used for persistence. That is a big reason why we use databases. So you might hear persistence layer thrown about through, if you ever work on large-scale applications, they're talking about a database. Persistence layer is just a database. So we use database to keep things around long-term and also to centralize our data so that multiple people or applications can access it. There are plenty of other reasons for using databases, but for our general purposes right now, those are the big ones. Those are the big ones. Coding things up, doing things in code like we have been doing is fine for small scale stuff, but imagine if I had 100 users, 1,000 users, it gets real tedious really fast to manage all of that in a code file. And that's not really what code files are for. Code files are for doing things, performing actions, not storing data, not housing data. That's what a database is for. So it's sort of along this line of separation of concerns. Our code is used to perform actions. It's used to actually do stuff. The database is used to hold information. And we don't mix the two together. We just make them talk to each other when necessary. Are there any questions about that? It's an important concept. Very, very important concept. We good? All right, so let's dive in and start talking about more specific database-related things. Let's assume we have a database. We're just starting out. We already have a database. I want to get some information out of it, so I need to write a query to retrieve some information. What two clauses, I call them clauses, or you might, I think the prep work referred to them as clauses. I hope it did refer to them as clauses as well. What is required for every single query if I want to get information out? What two pieces do I need? Select and from. Those two are always required. What's the from do?
It tells you
Where it comes from. So from is going to tell me what tables I'm using. What's the select do? Columns. Select is used for columns. Yeah, it tells me what columns I want to use in the results set. Those are always necessary. Those are absolutely always required for retrieving information out of a database. What table am I pulling it from? Or tables, plural, multiple tables. And then what columns do I need? So speaking of multiple tables, what's a join? What does that do for us? What does a join do for us? From two tables and sticks it together. So this is a tricky concept, especially when you're first learning databases. I would not be surprised if there are some of you who are still a little bit fuzzy on the details of how this works. But it's very important. The way I think of a join, when joining tables together, I think of it as gluing them together horizontally. I'm taking some columns from this table, I'm taking some columns from this table, and I'm gluing them together, right, horizontally. And so how do I know how those tables are going to interact with each other? How do I know which values to take from this table and which values to take from this table? How does that work? Or in other words, what information do I need to even do a join in the first place? How does that work? You need keys, exactly. You need keys. So there's two different kinds of keys. Could somebody tell me one of them? Primary key, what's that one do for us? It's a unique identifier, that's what it is. It's a unique identifier. A lot of times it's just going to be a number. The first row that goes in the table gets a primary key of 1. The second row gets a primary key of 2. It doesn't have to be complicated. It's just a unique way of identifying every single row. That's important to us. To understand why, think back to that example I was using with a table about people. It's possible for people to have the same name. It's possible for people to have the same birthday. It's possible for people to have the same name and the same birthday. Right? All those things are possible. So trying to uniquely identify a person based on just that information doesn't work. And I need to know, if I say John Smith, I need to know which John Smith you're talking about. So that's why we have some unique identifier that we can use to distinguish every single row in our table. That's the primary key. What's the other kind of key? The foreign key, and this is where things get a little bit confusing, I think. What is a foreign key? Can somebody explain what a foreign key is to me? It's a column in one table. If I see a foreign key in one table, that value will be the primary key in some other table. So if I have a person column, the primary key will just be 1, 2, 3, 4, 5, 6, 7. But then let's say I'm tracking, oh gosh, what's a good example? Maybe I'm tracking orders, like shopping on Amazon, right? For every single order, I want to know the person who made that order. Who actually bought this stuff? Who am I sending this stuff to? So in the orders table, when I'm tracking the purchases that people have made, I will see that unique identifier that points back to the people table, the customers table, that says this is the person who bought this set of stuff. Does that hopefully make sense? So when we have a foreign key, what we're actually saying is that the numbers in this column, this foreign key column, mean exactly the same thing as the numbers that are found in this primary key column over here in this table. And that's important. We need to be able to make that connection. In fact, we have a name for that in SQL. What's that primary key, foreign key? What's that called? one-to-many, which is a type of relationship. Yes, it's a relationship between tables. So if, why do we bother? Why do we even bother with this? Why not just take all of our stuff and just make one big table and toss it all in? Wouldn't that work? Why do we even bother segmenting stuff out? Why do we even bother with the, yeah?
One of the examples they used was one person could direct multiple movies. So
Mhm.
you had to list out that person's name, address, contact information, agent, all that in the same table as every single movie instance that they made. It's a lot of extra data. So
Yeah.
use that.
So redundancy is a big reason why we do this. Think about, or even going back to our Amazon example. I buy stuff on Amazon all the time. Just ask my wife, it drives her crazy. We're getting packages every day. I got packages waiting right now. I can't wait to get home and open them up. If they had to copy my name and address and all of my details for every single order, that's a lot of duplication. My name would be showing up a lot. My address would be showing up a lot. By using a relationship, they can store my name and address and all of that stuff in one place and then link back to it. Just keep linking back to that one copy. Or another reason why it's useful, think what happens when I move. Or if I were to change my name or something like that, right? If I'm copying that information every single time I make an order, then when I change my address or change something else about me, I have to go back and update every single time that shows up. But if I just have one copy and I link back to it using a foreign key, then I only have to change that in one spot. And then it fixes everything else. Does that hopefully that makes sense to you? Hopefully that makes sense to why we bother with this process. And so, last but certainly not least, I think it's useful to try and visualize how a join actually works. So when I try to do a join, maybe I can pull up I'm trying to think of what's the best way for me to do this. I wish I had a whiteboard. I would love to sketch an example, but I don't have one right now. I have two tables. I see a primary key in this table and a foreign key in this table that relates them to one another. When I say join in the code, what do I actually see in the code when I perform that join? I say, from this table, join this table. What comes after that? On, and then it says the relationship. This column equals this column, right? So what that's telling us to do is look at the primary key here. Maybe it's the number 1. Go find all of the times that number 1 shows up in this foreign key column. Those are the matches. All right, you're done with customer number 1. Now look at customer number 2. Go find all of the times that the number 2 shows up in this column. Those are the orders that this customer has made. Repeat the process for every single one in the database. Does that kind of make sense? Hopefully that makes sense how that actually works. So every time it finds a match, it connects them together. If it doesn't match, then they just move on to the next one. Don't worry about it. That's how joins work. We're still kind of scratching the surface. Actually, there's one other question up here, just to confuse things a little bit more about joins. What's the difference between an inner join and an outer join? You definitely saw some outer joins in the prep work. I saw them in there. What's an example of an outer join? How do I know the difference in the code? What word am I going to see? Or words? Excuse me. Left or right or full is what we'd say. Let me give you a little tip. There's no such thing as a right outer join. Don't do it. Don't do it. If you really want to, just flip the tables and write it as a left outer join. What's the big deal though? What's the difference between a left? Think about the same join. One of them has that word left in there, and one of them doesn't. What's the difference? What is the difference?
Taking the information from the first table.
Yeah. So if I have a left join, all of the rows from that table on the left are going to be included, whether they match or not. So that's a little bit confusing because what happens if they don't match? How do I know what to fill in for those columns? What do I do? What does it put in its place? null. It just leaves it blank. I don't have that information. It doesn't exist. It just leaves it blank. You're not going to use outer joins nearly as much as inner joins. So if outer joins are confusing to you, don't worry about it. You still need to pick them up. They are still useful. You're still going to need to use them. But if it's confusing the topic, if it's confusing things for you right now, I would say just forget about it. Get the inner joins down. Work on your inner joins. Get those working. Make sure you understand how the inner joins work. You can pick up the outer joins later. The inner joins are much more useful, much more common. All right. Any questions about joins? It's a massive topic, so if you have any questions, you saw stuff in the prep work that you're still trying to process, be happy. Yeah?
When would you use a self-join?
A self-join, oh yeah, that's a great question. I saw that in the prep work and was just kind of blown, that my mind was a little bit blown that they were dropping that bomb on you this early in the process. The self-join is used oftentimes when a table has a relationship with itself, which might sound a little strange, but it does happen. It actually does happen. The easiest example that I can give to you is an employees table. So I have a table, I work at a company, I'm doing HR or whatever. I have a whole table with all the employees in it. Some of my employees are managing other employees. So I could have a relationship from the employees table to itself that says this employee manages this other employee or this other set of employees. And that's when a self-join might come into play, because joins are almost always going to occur across those relationships. So the good news is, if you don't see a table with a relationship to itself, the odds of you needing to use a self-join are slim to none. If you do see that kind of relationship, though, you might need to use a self-join. And self-joins are a little bit complicated. I suppose the other good news is that you don't need self-joins. They're not extremely common, at least not in my personal experience. I have not had to write many self-joins in my time working with databases. But hopefully that answers your question. If there's a relationship from a table to itself. Any other questions about joins or other stuff? Okay, let's talk about data types. What kinds of data types does SQL have? Integers, yeah. Text? What do we call text? We call it string. What's it called? What's the data type called in SQL? Text is actually an option. You'll probably more frequently see it referred to as char or varchar. You can say char if you want to, but I'm not going to recognize that as a valid pronunciation. Yes.
In W3 schools, that website, it has both varchar and text listed, and it says that text is like a string under 255 characters, and so is varchar. What's the difference?
To be perfectly honest with you, I'm not sure I know what the difference is between the two. I use varchar just because that is sort of what I grew up using. That's just what I've been using for many years, and I don't see any reason to stop now. But I honestly don't know. I don't know what the difference is. Yes?
In that same thing, it's like talking about different types. You can have a type for a large text that has like a really, really big number in it.
Okay.
Amount of characters you know. Is that common for tables to contain like a huge string like that?
Is it common for tables to contain huge strings? It really depends on the application, but that does bring up an important point. I want to talk about this. When I'm using varchar type, right, I have to specify a number with it, which indicates, what is that number actually telling us? It's the maximum number of characters. It's the maximum number of characters. So some of them will have that many characters, maybe. A lot of them will be less than that. It's the maximum number of characters. So oftentimes, you'll see those numbers, we guess large because we don't want to run into a situation where we don't have enough space. So you'll see that those numbers are oftentimes estimating a bit high, just to be conservative. You'll see that today actually as well. But that's something that we have to think about when designing databases. They do make you specify how big those need to be. So back to answer your question, do we ever see databases with text that large? I mean, I've certainly seen databases that try to do things like, processing the frequency of words or characters that show up in large bodies of work. So they might be storing entire books. But that's sort of a rare situation. Not every database is going to need that large set of text. A lot of times you're just storing names, addresses, things like that, which are relatively short. But it's nice to be able to do it if you need to. What other data types? So we had integers, we had the text ones, the various text ones. What else we got? Booleans exist. Although I think they might be called something a little bit different. Are they not? I'm trying to remember. I'm sorry? Bit, yeah, that's what I was looking for. I think it's just a single bit, binary representation of a bit. What if I wanted to put a picture or something into a database? Can I do that? I'm sorry? NoSQL? I don't think we need NoSQL to pull that off, but I think you could do it with NoSQL. I think you could do it in regular SQL too. Does anybody know? It actually is possible. I know I'm probably deviating from the prep work a little bit, but you might hear the term blobs thrown around. It stands for binary large objects, so pictures, videos, audio, those kinds of things. It's just sort of a miscellaneous bucket for stuff that doesn't fit any of the other categories. So you can put that kind of stuff in your database as well, and it's not uncommon to do so. But in general, the types we're going to be working with are the usual suspects: text, numbers. Can I do, so we said integers, can I do floating point values as well? Yeah, sure, absolutely. Dates and times are important. Databases. You'll notice that a lot of those data types we also had in Python, although some of them are different. Either they look a little bit different, they behave a little bit different, or we just didn't quite have the exact same thing in Python, or we haven't seen it very much in Python. But that's something that we should definitely be thinking about. We're not going to do much of it today, but on Thursday and into next week especially, we're going to be trying to think of how to take stuff that's in our database and match it up with Python stuff. And getting the data types right is a very important part of that. This column is an integer, so Python can handle integers just fine. This column is a date. What the heck do I do with that in Python? I don't know. We'll have to figure that out. So that's something that we're going to have to think about more and more as we go through. Cool. Any questions? Any questions about data type stuff? All right, let's talk about some various, I just sort of went through and picked some various SQL concepts at random that I thought might be worth talking about for the remainder of this little review session. So let's take a peek. So there were two clauses here, one called where and one called having. Those are both in the prep work. What's the difference? They seem very similar. What do we use? Let's start with just basic definition. What do I use where for? What does a where clause do for me? What does it do? I'm sorry? Selection? We have a select clause. Is that what I mean, you need to be a little careful. Filter. I like that word a lot better. Filter? Although I agree with you, I was being a little mean, right? When you said selection, sure, I don't disagree with you. But filter, it filters data out for me, so I can find people with a certain name or with a certain birth date or something along those lines. Actually, if I had to relate this to Python, what would you compare a where clause to in Python? An if statement. They're not exactly the same, but you can see the relationship, right? You can see the similarities between the two. So then this having clause popped up, I think, towards the end of the prep work today. What's the difference between these two?
Aggregating data, aggregated data.
Aggregating. So aggregations are a thing that our database can do. What's an example of an aggregate that you saw? Summing, averaging, counting, max, min. So I can aggregate things. I can take a whole bunch of stuff and aggregate it together. This having clause is typically There are always exceptions, but typically you're only going to see this if I'm using those aggregates. Average, count, sum, max, min. Then I'll see this having clause, because a having clause allows me to filter by an aggregate. That's the biggest difference. I can say having average greater than so-and-so, but I can't use average in a where clause. It's not allowed. You can't do that, which might seem a little bit arbitrary, might seem a little bit confusing. I agree with you. I think it's, not intuitive at all, but that's how it is. There are reasons why that's the case. What's another clause that we often see with aggregates? If I see an average or a sum or a count, what might I expect to see later on in my query? We'll talk about as, but yeah, I agree with you. There was another answer I was looking for. Group by, yeah, group by. What does a group by clause do? This is another, I think, topic that's can be pretty confusing when you're first starting out. Somebody explain what group by does for me? Did I see? We group them together. So let's see if we can, if I take an average, let's say I want to take an average of a column. I don't use a group by, right? It's just going to average the entire column and spit out one value. There's my average. If I use a group by, then it'll try and find values that match and stick those in groups and then take the average of each of those groups. Does that make sense? So instead of getting one average back out, I'll get multiple averages, one for each group of like values. In some cases, it's required to use a group by with aggregates. If you look at the select and you see an aggregation like an average or a sum, and you see another column that's not an aggregation, maybe it's somebody's name or something like that, I have to group by that non-aggregate column. It's required. It's necessary. And that's a very common mistake. If you haven't run into that mistake yet, you will. It happens. I do it. Everybody does it. We'll probably see an example of that just a little bit later. Yep, everybody does. All right. What does in do? What does the in keyword do for us? Where am I going to see it? Where am I going to see it show up? We're joining? Maybe. Not always.
An or list in your where or having clause?
Yeah, it's going to be in my where. Most often where, but it could also show up in having. You compared it to like an or list.
Or.
Yeah, instead of chaining it all together. Yeah, I like that. I like that expression a lot. We would say if I have a set of items and I want to match any item in that set, that's what in does for me. Actually, yeah, it's a good description of it. So it allows me to match multiple things, potentially. What about this word? What does like do? This one is another pretty confusing topic, but a super useful one. Have any of you started on user signup yet? I'm sure some of you have. And one of the things you had to do on user signup was make sure that they typed in a valid email address, right? Had to have an @ symbol in it, had to have a dot whatever. I forget what the actual rules are, but that was one of the things you had to do. What did you use to pull that off? There's a couple ways you can do that. You can go through the string character by character, but there's another way you can do it, and I know I saw some people doing it, called a regular expression. In fact, I thought the assignment might have even linked to regular expressions or shown you an example of regular expressions. This, the like keyword is SQL's version of regular expressions. We use it to match patterns. So if I'm looking for a piece of text that has an @ sign in it and a dot in it, this is what I would use to check it, the like keyword. Regular expressions are, I could spend a whole 3-hour session talking to you about regular expressions. They can get very complicated very quickly. So I'm not going to do that right now, but if you're interested in learning more about regular expressions, talk to me sometime. I'd be happy to chat with you about that. That's what the like keyword is for. What's an alias? What is that? Renaming, yeah, that's it. And if I want to rename a column, what do I say? As, yeah, that was a simple one. So when might we want to do this? Aggregates are one good option. Is there any other option, any other times you might consider renaming a column?
Self-join.
Self-join is another time that we saw the aliases pop up. Yeah, anything else?
Just make something easier.
If you don't like the name of the column, feel free to rename it. In fact, in this class, we're going to give you pretty well-formed databases, but spoiler alert, the real world, sometimes you get junk. Sometimes you get databases that don't look great. Sometimes you get databases with really weird names for things in them. Happens all the time. All the time. So if you don't like the name of something, rename it. Rename it to something that means something more to you. Please do. Last but certainly not least, what does top do? So if I have a query that returns 100 things and I say top 10, it's going to chop off everything after the first 10. We often see top used with another clause. They go hand in hand. I call them cousins. What clause am I usually going to see along with the top? Order by. Order by. Consider why that's the case. If I don't order things and I just say, give me the top 10, what am I going to get back? I'm just going to get 10 random ones back. Just 10 random things back, which maybe is useful to me, but usually it probably is not. So oftentimes I'm going to sort everything and then take the top 10. And we sort things with an order by clause in SQL. So I've been trying to do this as we go along, prep today, trying to sort of focus you in on some things versus other things. Of the stuff that was presented in prep work, knowing how to do joins, inner joins in particular, knowing how to write a good where clause is very, very useful to you. Knowing how to do aggregations with group bys, very, very useful to you. Those things that I just mentioned will get you very, very far. The rest of the stuff, absolutely good to know. I don't want you to ignore it by any means, but those things in particular will form a very solid base of SQL knowledge. And I would, if you're struggling to keep up with the prep work and wondering what to do or feeling a little bit overwhelmed by the amount of prep work that was on the docket for today, that's what I would recommend really focusing on. Joins, aggregates with group bys, and writing good where clauses. That's what I would really heavily encourage you to focus on. And then once you get those down, go take a look at the rest of the stuff, and it'll be easier for you to pick up after that point with enough practice. Was there anything from the prep work that you were hoping I was going to go into today that I didn't? Because this is actually all I prepped for the review section. We do have a walkthrough still, but anything from the prep work that you wanted to ask a question about before we move on to the walkthrough? Anything at all? Yes?
They keep giving us multiple examples from MySQL, SQL Server, Oracle, MyAccess, MS Access, which should we be focusing on?
Oh, okay, great question.
All into my brain.
Yeah, great question. So the question was, they show examples from MySQL and Oracle, and I already forgot the other ones, but there's other ones on there. We're going to be using MySQL in this class. The good news is, and hopefully you can see this from the examples, that they don't differ by all that much. There might be small changes here or there, but for the most part, they're pretty much the same. And that's true of the very basic stuff. Like anything that's in the realm of what we've asked you to look at today still falls under the realm of, basic SQL stuff. When you get into the more complex SQL stuff, the more complicated SQL queries, which honestly we're probably not going to dive into a whole lot in this particular course, then it really matters which database you're using. MySQL and Oracle are totally different once you get outside the realm of the basics. But if all you're doing is the basics, they're very, very similar. Very, very similar. And that's why when you write your resumes, especially, I wouldn't worry about claiming that you know MySQL or Oracle necessarily. Just say that you've got a basic grasp of SQL and applies across many different database types. It's more versatile that way. That's what it says on my resume anyway. All right. Any other questions before we hop into the walkthrough? Any other questions? Yes?
When you query a database, what's the return look like?
When you query a database, what's the return look like? Well, that's a good question. You could actually run some of these examples, right? On the prep work. I can try and pull one up real quick, maybe if I can. I don't know if I have the prep work open. but I can pull it up real quick. It's a good question. Let me see if I can pull one up and see. 2.7. One of the W3 schools is probably good. Come on now. Oh, wait. Whoops, did I do the wrong? Oh, that's, what did I do? Oh, I did the right thing. I just, yeah. I was in the right place. W3 schools. It doesn't really matter which one. Actually, this is fun. Well, let's pick something maybe a little bit more different than that. Let's pick like this one. Here's our demo database. Perfect. Run the SQL. So here's what the results look like. This actually looks kind of familiar to me. What does this look like to you? Looks similar to something else that we've been talking about. What does it look like? Rhymes with fable.
Yeah, it's a table.
It looks like a table, right?
Yeah.
It looks very much like a table. That's not a coincidence. That's not an accident. Is it a table? Is it a table? No, it's not. It's not. Tables are permanent. This is not permanent. This goes away. I can see these results, but as soon as I go to do something else, poof, they're gone. They're gone. But they share the same structure. The result set and a table share the very same structure. Everything in a database, in terms of what information, how information is stored, looks like this. Everything. In fact, you may have heard the name relational database. That may be a term that was in the prep work, or you might have heard it thrown around. This is called a relation. That's where it comes from. And relations are built on algebra. It gets very mathy. We didn't ask you to do all that math. You're welcome. But I know that math. I like talking about that math. So if you want to know the mathematics behind databases, come have a chat with me. I'd love to talk to you about that. But it's not a coincidence that it looks similar to a table. The interesting thing to keep in mind, especially if you get into like joins, so take a look at a join example that they have here. This also looks like a table, but this column comes from one table and this column comes from a different table. But it looks like they've been merged together into one, and actually they have. Right? For the purposes of these results, they've been merged together. But it's not a table. We call this a result set. It's probably what I most often would call it, or just the results. Probably what I'd call it most often. What other questions do you have before we hop into the walkthrough? Yes?
These result sets, are they like a view in Python?
I would not use the word view, because views are something that exists in database that means something different. Although I'm not familiar with a view in Python either. I mean, they might be referring to the same thing. But this is not a view. I would definitely not call this a view. This is a result set, period. Yeah. We might see views a little bit later. What other questions do you have about database stuff? Questions? All right, so we do have a walkthrough today. We're not going to be doing flick lists. We're not going to be programming the Python code that we've been working on the last few weeks. We're going to do some database stuff instead. Now, the interesting part about today's studio and the walkthrough is that we don't actually have a database to work on yet. We have these examples, right? But this isn't our database, and we actually can't change the stuff in this database very easily because it's not our database. So on Thursday, what you're going to do is install a database on your computer, and you're going to use that database with your application. So by the time you show up on Thursday, you'll all have databases on your laptops, on your computers, which is cool. But we don't have that now. So we want to do some coding practice with databases. We don't actually have a database. So we're just going to do the best that we can. We're going to open up, I would suggest that you open up a text editor or some other place where you can just type out some stuff. The downside of this process is that we won't actually be able to check to see whether the stuff works or not, which I know is a little bit frustrating, but that's just what we got right now. On Thursday, we'll actually be able to test this stuff out and see that it works the way we expect. Yeah?
With Macs, they come with SQLite 3.
Oh, okay.
It's just, if you want to pull it up in terminal,
Oh, interesting. I've been informed that Macs have SQLite 3 installed already, so you actually could use that if you want to. I'll be honest with you, I don't use a Mac, so I know very, very little about that, but if you're a Mac Pro out there and you want to give it a shot, I say go for it. If you're not on a Mac, don't worry about it. We're going to have you install a database for Thursday. So we're getting there. Today we're just going to do some practice. So I would open up a text editor. That would be what I would suggest. You can use Code, the Visual Studio Code if you want to, or just any old text editor. I have this Notepad++ program that I like to use. And what we want to talk about today for our walkthrough is kind of a design. We kind of want to think about what, if we wanted to put a database in FlickList, which we do, what would that database look like? That's what we want to talk about today. How would we structure that database and then kind of think about how we might use that database for FlickList. So we want to create tables to represent movies and directors. We actually want tables for more things than that, but this is just going to get us started. I want to create a table for movies. I want to create a table for directors. That's the goal for this walkthrough. That is the goal for today. So whenever I'm trying to design a database, whenever I'm trying to think about how to construct a database, I want to try and think about, okay, I know I want a table for movies, but what are the columns? That's probably the next thing on my list. What columns should this contain? Any ideas for columns for this movies table? Directors. Oh, hey, it's a little meta, but it's true. Director is going to be what? You started out with the hardest one. That's okay, though. We're going to have to handle it sooner or later. What is this? I'm sorry? It's a foreign key. It's going to be a foreign key. If that doesn't make sense to you, sit tight. We'll come back to that in a moment. Let's pick up some of the maybe more straightforward ones first. What else do I expect? Title. Perfect. What else? Year. Sounds good. Runtime? Sure. What else we got? I'm sorry? Rating. Genre. Yeah, lots of good ideas. Country. These are all great ideas. There's probably more. But I mean, honestly, this is fine. This is totally fine. Actually, for our implementation, we're not even going to include all of these, but we will include some of these. There's one actually very important piece of information that's missing that I'm sorry? Primary key. We need a primary key. So I would often call that like a movie ID or something like that. I forget what the actual walkthrough suggests that we use for a name, but that's usually what I would use. Okay, and then for the directors, what kinds of columns might we expect to see? Name, perfect. Any others? We need a primary key. And that's actually very important because this primary key, in fact, maybe we should mark them as such. Primary key. It's important that we have a primary key here because it's going to refer to this foreign key is going to refer back to it. So what that means is that, Steven Spielberg is going to show up in our directors list, right? He's going to have a director ID of 1. And then all of the movies that he's ever directed in this column will have a 1 there, meaning that this movie was directed by the director with this primary key, who is Steven Spielberg. That's how the relationship works. What else should we have in this table? Country, sure. What was the other one? Number of movies made. What is that? That actually sounds like something. What does that sound like? It sounds like an aggregate. I could do count if I wanted to figure that out. So, birth date, sure. I'm sorry? Awards. Okay. Awards gets a little tricky, actually, because it's possible for a director to win multiple awards, right? They don't just have to win one. But yeah, Okay, this is certainly, I think, plenty to get started with for now. Let's actually take a moment to take a look at the studio and see which ones they want us to use. So we want to have the title, the year, and who the director is, as well as the movie ID column. But we also know that we want to have the foreign key for directors. So I'm going to put stars next to these, just to indicate. Whoops, hit the wrong button. I'm going to put stars next to the ones that we definitely want to keep. Not that these other suggestions were bad. I actually think they were great. We're just going to simplify things a little bit. So the ones with stars next to them are the ones that we're going to keep. And then for the directors, I don't even actually remember. I think it wants director ID and name. What was the other one? It doesn't actually say. Well, we'll come back to that in a second. So the next thing that I like to do when I'm creating these databases or creating tables, we need to think about not just what columns exist, but there's some other information we need to know about the columns. Data types. So for each of the columns, we need to think about what data types they should be. So for a movie ID, what kind of data type do I expect here? Integer. What about for the title? Text or varchar. If I say varchar, I need to specify a size, and that's where things get a little bit tricky. You always want to guess big, be conservative, put a larger number here than you think that you will need. So I don't know, 100 characters or, right? That seems like overkill, right? But we always guess a little bit larger. What about for a year? I'm sorry? Integer? Is there any other data types that we could use here? Date time. Or actually, in some databases, not all of them, there actually is a data type called year. I don't know if MySQL has that or not, but it definitely has date time. I know it has that one. The walkthrough actually spoils this and has stuff for us to use eventually, which we'll get to. What about for the director? What's this going to be? Integer? There's some other things that we also should decide about these columns. Namely, do I want them to, can I allow them to be null values or not? Is it okay for the title of a movie to be blank? No, usually not. Usually that's not okay. So I would say not null here to indicate that this value has to exist. They have to tell me what this is, right? They have to specify what that is. For the year, that one I might be willing to be a little bit more flexible on. If you know the year, yeah, you should definitely tell me what year it was made, but for some of the really old movies or for some obscure movies, maybe we don't know exactly what it is, so I'm willing to be a little bit more flexible on that. I'm sorry? Movie ID should be not null, however, by declaring it as a primary key, that does, when I declare a column primary key, it really does a lot for me. Can't be null, has to be unique. In fact, there's something else that usually goes hand in hand with the primary key when creating tables. Do you remember seeing this in the prep work? Auto increments. What does that do for us? It just counts for us. Not that counting is hard, right? But it lets the computer manage the primary key. The idea here is that if we don't let the computer do it, that means that I have to do it, and I might screw it up because I'm a human. Whereas if we let the computer do it, it's just going to count properly, and then we don't have to worry about it. So when I put auto increment here, this goes even farther and basically says, this is the primary key column. Nobody's even going to touch it. Don't touch. You can look. You can take a look at the info and use it if you want to, but don't touch it. Don't change the values. Don't put the values in. Don't take the value. Well, you can remove rows if you want to, but you're not going to mess with the primary key values. You're just going to let the computer do it all for you. And so we'd have the same idea for directors. Primary key is going to look very similar, I think. Integer, auto increment. Name is going to be varchar. Again, pick some large value. I don't know. I mean, 100 is kind of what my go-to, but nobody's going to scream at you if you go a little bit larger than that. Although there is a limit. 1,000 would be a little ridiculous. 100 sounds a little ridiculous, but honestly isn't that bad. And so this is the point then where I forget what the walkthrough told us to do, so I need to go take a look at the walkthrough. So the walkthrough has us do exactly this. We did the data types, we did all that. I already talked about mapping things to Python a little bit later. So this is the ultimate goal that we wanted to get to. How do I create a table with all this information? Some of you are probably looking at this. And there's a problem here with this first version. And you can read about the problem if you really want to, but just from taking a look at the code, can you see what problem this particular table has? I'm sorry? Director's not set up to be a foreign key. In fact, to take it one step farther, the name of the director here is particularly problematic. We're using a varchar for the name of the director. Why is that a bad choice? Why is this a bad choice for the type of this?
You want to join on the ID, not the name.
So we know we want it to be a foreign key. My suggestion here is that even if we didn't know that we wanted this to be a foreign key, that a text would be particularly problematic. Because what does this mean? How many movies has Steven Spielberg directed? A bajillion, right? So every movie he directs is going to have his name stamped on it. Steven Spielberg, over and over and over and over and over again. That's duplication. It's redundant, right? It's not good design. If Steven Spielberg were to do something crazy like change his name, which he would never do because that would just be silly, but if he did, then I'd have to go find him everywhere and change his name everywhere because it shows up so many times. It's duplicated. Not only that, but let's say there's another guy out there named Steven Spielberg who's also making movies. I don't think that's true, but it could happen, right? There's another guy out there named Steven Spielberg directing movies. Now I see his name show up, and I don't know which one you're talking about. I have no idea if you're talking about the big famous Steven Spielberg or the other Steven Spielberg. So, using text here is not a good choice. I want to use a foreign key, but that actually has an effect on what we do next. If I want to create a foreign key here, what's the order of stuff that I should do? What should I do first? If I know this is a foreign key, what should I do first? Which table? Directors. It's better for me to create directors first because this table wants to link back to it. But if it doesn't exist, that's a little bit trickier. It's actually not impossible. It's just a little bit trickier. So I really want to do directors first because of this relationship. So let's see what columns. I'm going to try not to cheat. Okay. Here's something actually that's good to talk about. So they want name, we had name, country, and a director ID. So we actually had country. What should the data type for country be? Varchar, perfect. Of whatever. Now, for name, you'll notice that they actually had first name and a last name, whereas I just wrote down name. Which one's better? First name and last name? Why? I'm sorry? More specific with queries? I like to think about it this way. It's possible, if I give you the full name, right? It's very possible for you to figure out what the first name is and the last name is. If I give you the two pieces together, it's also possible for you to go and get the full name. Which one is easier, though? Yeah, it's definitely easier to take the two small parts and glue them back together than to take the one big piece and chop it up. So when working with databases especially, if there is a way for us to logically break down a larger piece of information, we generally prefer that. And names are a classic example. Addresses are also a classic example of that. I usually don't want to store the address as one big giant thing. I want to take the street, the state, the city, the zip code, keep all of those separately for the same reason. It's much easier to stitch them back together than it is to chop them all up. So we need to kind of redo this here. First name and last name. And the data types could be similar. 100 characters is actually probably way, way, way overkill for these, but it's all right. And so we want to actually create this table, and this is similar to what we're going to have you do. I know the answers on the walkthrough, but you know, roll with me here. I actually want to create this directors table. So I say create table, and then I say directors, which is the name of the table. What comes next? I'm sorry? What comes next? Parentheses. There it is. Parentheses, and then what?
Whatever your values for your
And then I just start dumping columns in there, right? And actually, you'll notice that the way I designed this, it was somewhat intentional. This looks very, very similar to how I would expect it to show up. Not exactly the same, but very, very similar to how I would expect it to show up inside of this query, right? I did it that way somewhat intentionally. So, you know, primary key, integer, I don't need the dash in there. But everything else is okay. The one thing that kind of bothers me a little bit is I'm a little overzealous about this. If you don't agree with me, that's your right to do so. But I am a little overzealous about capitalization. Also, is auto increment one word or two? I always forget. One word. Underscore. Like that. Thank you.
Does integer have to come before primary key, or does it matter?
That's a good question. Does integer have to come before primary key?
when I did it.
My gut is saying probably, but I'm also saying give it a shot and see what happens. I think actually the data type does need to come first. Overkill. Data type comes first, and then any modifiers like primary key, auto increment stuff come after the data type. Pretty sure that's what would need to happen, but give it a shot and see. And so then I put in a comma, and I just keep listing off columns, right? So first name, varchar 100, last name, varchar, varchar 100, country. So there's all of my columns. And I think I just need a parenthesis. Am I good? Semicolon? Oh, I'm missing commas. I always forget those. Thank you. Am I good? I think so. Now, as I said, I'm pretty overzealous about capitalization. I capitalize a lot of stuff in SQL. Does SQL care about that? No. Doesn't mean you shouldn't do it. I think it helps readability. That's why I do it. I really think that it helps you read a query and understand what it's doing. If you type everything in lowercase. Does SQL care about white space like Python does? Nope. So this query and this one, right, are functionally equivalent, but which one would you rather read? Not this one. Definitely this one. So again, SQL is actually fairly loosey-goosey when it comes to what it will accept in terms of style and what it will not, which is kind of a good thing. But just because it's loosey-goosey doesn't mean you should be sloppy. I still think there's a good reason to be careful about your queries. So this table, or this statement, should create the table, and then we can create the second table. We'll check our work afterwards. Did I skip something? Am I missing a parenthesis? Okay, thanks. Good looking out though. I very possibly could have done that. So now I can create my movies table, and it's gonna, share some similarities to this one. It's good practice. Again, I can kind of refer back up to here. Movie ID, here's all this stuff. The order's a little mixed up, and I'm crazy about the caps, as I mentioned. But, oops, I don't know why I deleted that. Yeah, I'll just type it all out. I'm a fast typer. Boom. We had the title, which was a varchar, something like that. I was going to declare it not null. I don't remember if the walkthrough actually did that or not, but I'm going to anyway. I believe the walkthrough actually called the year an integer, which is actually, I'm okay with that. I'm okay with that. And now the last part, this is the part where I want to have a chat with you. We're going to include the director. Although I would actually take this a step farther and call it the exact same thing as the primary key column. I would keep those names the same. There's no reason not to keep these column names the same. How do I actually hook it up though? What comes next? How do I actually take this column and hook it up so that it points at this one? What do I have to say? Nope. So a join, a couple people said join, and I understand why you said that. A join is what we do when after the relationship has already been created, after it exists, and I want to actually get data back out. Then I use a join, but we're creating the relationship right now. We're actually making the relationship. It does not currently exist. We want it to exist. So we're creating this relationship. So I'll say the type like I usually would, and then I'll say foreign key. I'll indicate that this is a foreign key. And then how do I point it at the other table? What do I say? References. And then what? The name of the table. Parentheses. The name of the column. I think my syntax is okay. Missing commas, yeah, well, that's pretty standard for me. Thank you, though. I always forget those commas.
The walkthrough has a comma between integer and foreign key.
Oh, does it?
Yeah, is that
That's a little surprising to me, actually. I guess it probably would work. I don't actually think it's required, but I could be wrong about that. I wouldn't be surprised if I was incorrect about that. It is worthwhile to see what the walkthrough was telling us to do, though. So here's what they had for the directors table. They used even larger values than I did, which is fine. That's okay. These names I'm actually not a huge fan of in the walkthrough. First, what? I mean, we know it's a name, but it's not. It could be more clear, in my opinion. Could be more clear. And then for the movies table, here's the foreign key. Oh, I see what they did. Yeah. I actually think that this is valid. I don't think that there's anything wrong with this one either, but maybe there is. I mean, their syntax was a little bit different. Their syntax looked like this, I think. It was foreign key. I had it backwards.
Yeah.
Sorry. Their syntax was just a little bit different than what I had up here. Like that. And in typical computer science fashion, there is not just one way to do this. There are multiple ways of doing this. There are multiple valid ways of putting in this information. So I think the way I had it up here was reasonably correct, or somewhat close. I also think that syntax, especially at this level, is less important than understanding the pieces and how they interact with each other. Syntax is easy to look up, which is why I don't spend a whole lot of brain space on it. I just do the best I can and then look up the problems that I have when I run into problems. Yes?
The value of declaring foreign key.
I'm sorry?
What's the value of the point of declaring foreign key?
What's the value of declaring a foreign key?
You gotta still make that join query.
You do.
Whether it's foreign key or not.
Yeah, you do still have to make that join whether it's declared a foreign key or not, but the foreign key does do some other useful things for us. One of the biggest things that it can do for us is help us validate referential integrity. So think about it this way. We're saying right now that every movie has to have a director. We're making that statement. A movie has to have a director. Not only that, but we have to know who that director is. So if I see a value in this column, maybe I see a director number of 200, but director number 200 does not show up in this table, that's no good. It'll toss it. It'll say, I don't know who you're talking about. I don't know who this director is. You cannot have this director in the table. That's called referential integrity, meaning that if I see a number here, it actually exists in this table, and I know who that is. Yeah. It's a good point, though. We do still have to do the join. Do I have to do a join on a primary key foreign key column? Do I have to? The answer is no. Actually, I can join any two columns I want to. Any two columns I want to, as long as the data types match. I can join them. That's a really bad idea. Don't do that. Maybe one time out of 100, that is a good idea. 99 times out of 100, not so great of an idea. We want to join based on our relationships. Yes?
Set something as a foreign key after you create a table?
You can, yes. It is possible to set foreign keys after you create a table. There's a statement called alter table, which allows you to change table definitions, which will allow you to set foreign keys or even add columns or change data types after a table's already been created. Yes, absolutely. What other questions do you have? I actually think we hit the end of the walkthrough. What other questions? Yeah.
Foreign key is an attribute here.
Okay.
Sorry, that was a question.
Oh, foreign key is an attribute?
Is foreign key.
Yeah, I mean, it's describing information about this column, yes. It's giving us additional information about this column. Yeah. We'll actually see on Thursday, after you install a database, we'll actually create these tables, and it'll be a lot easier for me to show you these relationships and make connections between them once we have some actual data to play around with. Thursday's gonna be a lot of fun, actually. Come to class on Thursday, it'll be good. Any other questions? So for Studio today, we've got these statements, right? And they're in the walkthrough as well. I think these are almost exactly the same, if not exactly the same as what's in the walkthrough. So you've got these tables, and then there's what, 8 questions down here that they want you to write SQL to answer these. I'll regroup us at 8 o'clock like I usually do. I don't know if I have time to do all 8 though. So as you're going through these, if there's any that you have questions about, just make a note of it, because I'm probably going to ask you which ones of these you want me to do. So pick out your favorites, pick out the ones that are confusing to you, and we'll do those at 8 o'clock. Otherwise, let's break up into our groups. Thank you, everybody.